Hello and welcome to my podcast. Whether you are driving to work, sitting down for a cup of tea, or walking the dog, there is never a better time to discuss the importance of bivalves as indicator species. Bivalve species consist of a soft body encapsulated in a pair of half shells known as the valves, connected by a hinge. These species are filter feeders, meaning that water enters the bivalve's body and passes through a series of filters where large particle matter is removed, while zooplankton is trapped in cilia, a mucus-like structure which then allows for it to be ingested. Due to the nature of these species being filter feeders, they are more sensitive to environmental changes within the water, such as pollutants entering the water via agricultural runoff from an untreated local drainage system, which exposed to can lead to changes in behaviour, physiological evolution, and mortality rates. Due to their increased sensitivity to anthropogenic stressors, these species are more likely to show a change in ecological behaviour before other species, making them a suitable bioindicator. Bioindicators allow researchers to understand the environment, both aquatic and terrestrial, in order to monitor the conditions, providing valuable information to both stakeholders and conservationists about not only the bioindicator species but other species that play roles within the same ecosystem. This has been shown in multiple studies around the world, such as a study completed by Loris et al. In 2022, which indicated how bivalve species can be used to detect antibiotic agents within an environment due to irresponsible disposal of medical waste. When discussing Rutland water, it is important to understand that Rutland is a freshwater man-made reservoir, which receives its water from River Here and River Welland and plays host to 8 lagoons. Not only is the reservoir a site of special scientific interest and special protected area, it is also noted as a Ramsar wetland of international importance due to the variety of species it hosts both seasonally and year-round. Rutland Water receives the majority of its funding through grants and partnerships, as well as donations from both the public and private bodies. This is received on the understanding it goes towards the research and development within the reservoir. Therefore, in order to be eligible for such funding, monitoring must take place in order to improve the facilities available, as well as key stakeholders such as local fishermen using the particular lagoons for species present such as trout, pike, and zander. Not only do these lake structures provide habitats to the latter species, they also play host to the swan mussel. The swan mussel is a sedentary species, meaning that they are largely immobile. This allows them to reflect prolonged environmental conditions in one area, allowing researchers to directly research particular areas within the lagoon without facing the worry that individuals may move areas depending on the exposure to clean or polluted areas. The average lifespan of this species in particular is estimated to be around 45 to 80 years. Therefore, this also allows the species to accumulate pollutants such as metals within their tissues over their lifetime. Even if exposure has been seen at low concentrations, this can provide researchers with data far exceeding the current climate of the environment. This was recently demonstrated in a study in 2023 carried out by Lamine et al., which found metal pollutants present in bivalves despite recent improvements and monitoring of ecological systems, providing clarity to the theory that these pollutants can still be present and stored within the specimen despite no longer being in the same historical conditions. It must also be noted that this may also be the case for toxins present in younger species, determined by life stage, size, etc., due to an ability seen in both mollusk and chondrothes species, where half-life pollutants can be passed on to embryo from the mother. The swan mussel also has a large distribution within both lakes and rivers throughout the UK. This allows for conditions in which an individual is present and the level of sod to be compared to those within other areas, allowing Rutland to use previous data sets to implement changes necessary to improve water conditions for not only the swan mussel, but other species present within the ecosystem. Therefore, with the above quality stated, this species makes a relevant bioindicator within Rutland. Monitoring this species is also relatively easy due to their sedentary nature. This would include collecting specimen samples annually, particularly in the autumnal months, due to the fact that this species has a breeding season that occurs in the spring months. This is to reduce young, sexually mature specimens being collected, leading to a decline in sexually mature breeding individuals in the future. Specimens should also only be collected if they are within a set measurement. In the case, a shell width of 10 to 14 centimeters indicates that the specimen has transferred into their adult life stage. Although this nature removes the option to use other monitoring methods, such as capture mark recapture, as these specimens lack the ability to move and relocate. Therefore, a more invasive method to monitor this species must be taken, this method being sod activity assay, which involves the dissection and eventual death of individual specimens. In order to determine the level of superoxide dismucus, or SOD, an antioxidant enzyme which is produced to protect a specimen from increased oxidative stress levels, causing harm to the gills, liver, and kidney-like structures. Oxidative stress is caused by exposure to environmental stress such as pollutants, metals, and organic decomposition. Due to their sensitivity to their environment, the presence of SOD can appear incredibly quickly, even at low levels, compared to other aquatic specimens within the same area. The need for a dissection to take place in order to see and understand these levels is relatively feasible due to the fact that the species is currently not present on the list of sentient species listed on the Animal Welfare Act 2006, later amended 2022, nor listed as a protected species by UK law. Therefore, only permission from the body of the area that the specimens were removed from, as well as ethical approval and compliance with the Animal Scientific Procedures Act 1986 is needed. This means that in order to perform SOD activity assay, permission from the area in which the specimen is being collected from, particularly from Rutland due to it being a site of special scientific interest, is necessary. As I wrap up on my findings for you, in regard to the use of swan mussels and their roles as bioindicators within the Rutland water, I will lastly leave you with reasons and predictions for both why and how SOD levels may be so high in bivalve species. The reason for high SOD levels in bivalve species within Rutland, in particular, could be due to increased anthropogenic activity in this area. This could be due to a range of factors such as agricultural runoff entering water systems, affecting individual specimens more extremely in areas such as buffer zones where pollutants and pesticides directly enter the reservoir. Alternatively, nutrient overloading entering the system caused by increased levels of nitrate or runoff may lead to low oxygen levels within the water, leading to detrimental effects to an animal that survives in high oxygenated water. Due to the area in which Rutland is located, surrounded by both large cities and towns such as Leicester and Nottingham, water systems may be impacted by industrial pollution such as heavy metals entering the water. This may include materials such as lead and mercury, detrimental to the species' health with the ability to cause cellular damage as well as affecting filtration ability. Heavy metals could also affect the food web at a higher level, affecting predation species such as piscivorous birds, creating a larger impact to the ecosystem as a whole. Warmer temperatures caused by climate change also have the potential to affect water quality by producing algae blooms, reducing the amount of oxygen within the water, affecting swan mussel filtration ability. Invasive species also have the ability to affect SOD levels to prevent levels present in bivalves. This can be down to increasing resource competition. Although some particular species, such as zebra mussels, often from parasitic relationships with swan mussels by attaching to their shells, reducing their ability to move and feed, altering nutrient cycling. These anticipated impacts are primarily due to anthropogenic impacts that we as humans are creating every day with irresponsibility and lack of knowledge. Therefore, I ask you, after listening to this podcast and reading my poster, to have a deeper think as to how you can reduce your impact on the environment and increase species diversity within protected areas. I've been Louisa Osborne. Thank you very much for listening.